Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals, right? So here in this class we are going to evaluate this definite integral where the integrand is absolute value of 2x minus 1, right? And the limits of integration are from minus 1 to 2. So let us see how we can evaluate this definite integral involving the modulus function using the concept of mod function or absolute value function, right? So here we are going to split this integral as a sum of two integrals, right? So here we'll find out the critical point, and the critical point can be obtained by equating this term which is inside this mod function symbol equal to 0. So let us write 2x minus 1 is equal to 0. So we have 2x is equal to 1, x is equal to half, right? So here the critical point is x is equal to half, and moreover here this function, that is our integrand, suppose our integrand is f of x, that is mod of 2x minus 1. So this function is continuous for all values of real numbers, that is x belonging to the set of real numbers, except this function is not differentiable at x is equal to half, right? So this function is continuous for all values of x which belongs to the set of real numbers, but this function is not differentiable at x is equal to half, and this function is differentiable for all other values of x belonging to the set of real numbers, excluding this point x is equal to half. So let us take this integral as I. So now let us define the mod function. So mod of p is defined like this. Mod of p is equal to positive p whenever p is greater than 0. Mod of p is equal to 0 when p is equal to 0. And mod of p is equal to negative p when p is less than 0, right? So here we can now define mod of 2x minus 1 with the help of this definition. So replacing this p by 2x minus 1, here we have positive 2x minus 1 whenever 2x minus 1 is greater than 0, that is x is greater than half, right? And a mod of 2x minus 1 is equal to 0 whenever 2x minus 1 is equal to 0, that is x is equal to half, which is our critical point, and at this point the function is not differentiable, and mod of 2x minus 1 is equal to negative of 2x minus 1 when 2x minus 1 is less than 0, that is x is less than half, right? So now we can split this integral at this critical point, that is x is equal to half. So here we have the real number line. So here we have 0, here we have minus 1, and here we have 1, that is plus 1, and here we have half, right? So now we can here write this integral I as minus 1 to half, that is first we'll write the limits from minus 1 to half, and then here we have half to 2. So here we have 2. So here we have half, and here we have 2, and here we have a mod of 2x minus 1 dx, and here we have mod of 2x minus 1 dx, right? So now see, when we integrate from minus 1 to half, then all the values of x are less than half, right? So when x is less than half, then mod of 2x minus 1 is equal to negative of 2x minus 1. That is, mod of 2x minus 1 is equal to minus 2x plus 1. So here we have now minus 1 to half, and here we have minus 2x plus 1 and dx, and here we have half to 2. So when we integrate from half to 2, then all the values of x are greater than half. So mod of 2x minus 1 in that case is equal to plus 2x minus 1. So here we have plus 2x minus 1 dx. So now we have two simple integrals. So here we have minus 2, and the integral of x dx is simply x square over 2, and the integral dx, that is 1 dx, is simply x, and limits are from minus 1 to half. And here we have 2, and the integral of x with respect to x is x square over 2, and here the integral minus 1 dx is simply x, and limits are from half to 2. So now here 2 and 2 get cancelled, so we have minus x square plus x, and minus 1 to half, and here we have 2 and 2 get cancelled, so we have x square minus x and half to 2, right? So now our aim is to just substitute the limits, and we'll take the difference. So now let us substitute the limits and we'll take the difference. So first we'll take x is equal to half. So here we have half square is 1 over 4. Then we have half, and then minus 1 square. So here we have this negative sign, and then minus 1 square is positive 1. And then here we have minus 1, and then we have here 2 square is 4, then we have 2, and then we have the negative sign, and here we have half square, that is 1 over 4, then we have half, right? So now let us simplify this expression. So we have here 4, and here we have minus 1 plus 2, and then here we have minus 2, then we have here 2, and here we have 4 1 minus 2, right? So now we can write the value of this integral I as 2 minus 1 is 1, so we have 1 over 4. Here we have plus 2, then we have 2, and here we have minus, and minus 1 over 4. So this is 1 over 4 plus this is 2 plus 2 4, and this is 1 over 4. So now we have here this 4, and 1 over 4 plus 1 over 4 is 2 over 4. So we have 4 plus half, and then we have 2 times 4 is 8, 8 plus 1 over 2, that is 9 over 2, right? So the value of this definite integral is equal to 9 over 2.